Good morning. Today we will talk about zigzag transformer. Here we will see the concept of how zigzag transformer basically works. Then in further videos we will see its application. Let us start with simple two-winding transformer. Here the same limb of the core, two windings of same equal number of turns have been inserted. The winding start is S and finish is F. So for winding number 1, the start is S1 and finish is F1. Winding number 2, the start is S2 and finish is F2. Let us short S2, F2. Now, if we apply a constant current from a current source from S1 to F1, magnetic flux will be produced in the core. To oppose the same, current will flow from F2 to S2 inside the winding. Since both number of turns are equal, the same applied current I flows through both windings. Now, let us insert two more windings, winding 3 and winding 4, in the next limb of the core. Then, parallel winding 1 and winding 3 by shorting S1 to S3 and F1 to F3. Similarly, parallel the winding 2 and winding 4. Let the short of the winding 2 remains as it is. Now if suppose we apply a current, the same current of I to the parallel combination of coil 1 and coil 3, the current will get divided by 2 and each winding will carry a current of I by 2. And the same current, because number of turns being same, the same current will induced in the coil number 2 and 4. So all the windings will carry a current of I by 2 in this case. The next step is insert two more similar winding in the third limb of the core. Now winding 5 and winding 6 occupies the third limb with the same number of turns. Let us repeat the same exercise of paralleling the primaries and paralleling the secondaries separately and apply a current of I to the primary, and we will see each winding will now carry I by 3 current and total I will get returned to the respective primary and secondary. Let us go back again to the first step, wherein I current was flowing in the first winding and I current was induced in the second winding. Since both are the same current, we can short F1 to F2 and then removing the short in the secondary, we can connect the return the S2 to the source I itself. So this picture will be clear what I say. So now also the same current I will flow in the winding 1 and return through winding 2 and return to the source. Hope this is clear. Let us do the same exercise for second set of coils by removing the short between F1 and F3 and connecting F1 to F2 and F3 to F4 and taking the return current of S2, S3, S2, S4 to back to the current source. Now I by 2 will flow in each winding and return to the source as I. Now let us make a twist. Instead of connecting F1 to F2 and F3 to F4, we can connect F1 to F4 and F3 to F2. Even now, the current same I by 2 will flow through all the windings, each winding, and then return to the current source as I. Listen to the diagram clearly for better understanding. The same logic we can extend to the three sets of coils, the three crores. So here F1 is connected to F4, F3 is connected to F6, and F5 is connected to F2. Now the same I by 3 current is flowing in each winding and returning the source as I. So this is clear. Now the zigzag transformer is going to take birth. Let us remove this current source for clarity and then connect the short S1, S3, S5 to a neutral and connect the neutral to the ground. Then remove S2, S4, S6 short and take those S2, S4, S6 to outside as a RYB. Connect to the RYB faces. That forms a zigzag transformer. What happens now? The current from the neutral is divided by 3 and flows through each winding and returning to RYB phases. What is the source for the current? The current may be a 3I0 from the ground fault, the system, or it may be a 3I0 due to unbalanced load, or it may be 3I0 due to third harmonics in the neutral. It may be anything. So that current gets divided by 3 by means of the zigzag transformer and being supplied back to the phases RYB where it has been connected. In our discussion so far, there is no phase shift between any current, any branches. So what it indicates, the zigzag transformer will conduct the current when all three phase currents are in equal phase, in equal magnitude with the same phase. What is that current called? That is the zero sequence current only can flow in equal magnitude but with the same phase. If we have connected the coils like this, the same core, seriesing both coils in the reverse way, then what would have happened? Now when we connect the same to or phase to neutral, the or phase neutral will get shorted because the flux produced by the bottom coil is opposed by the top coil of the same phase. So in normal scenario, it will get short circuited. When we connect the first coil to the second limb coil, then the flux will start rotating. It will not get cancelled. Okay, this is a picture. Here F1 has been connected to F4, the second limb. So the first coil produces the flux in the upper direction, whereas the second coil produces the flux in the downward direction. So from the first limb to second limb, the flux circulates. Even when there is one more coil in the same limb, that flux will also not be get cancelled because it is from the different phases. So let us see how the vector diagram works here. The voltages are equal in each coil, and then each coil is added with another coil of other phase in a reverse direction. So the vectors we are supposed to add at 60 degrees. So if we add different vectors at 60 degrees, we will get the original applied voltage. So for example, S1, F2 R phase voltage is added to F2, F2 Y phase reverse voltage, then we will get the resultant R phase to neutral. Here this is a different connection. Instead of F1 connected to F2, we have connected F1 to F4. So here the vector diagrams differs. So if you keenly note it, what is zigzag transformer? It is a star, part of the star and part of the delta connection. So how the voltages ratios are divided, you can see in the diagram. This diagram shows how the zero sequence is filtered by the zigzag transformer. This is a typical example. Because of time limitation, I am stopping it here. So hope you would have enjoyed this. Thank you.